All right. Hello, everyone. Welcome. My name is Four, and you're in Intrusion Along the Kill Chain. Thanks for coming. I really appreciate you guys having me out to this conference and spending some time with me today. Um, let's do a little bit of introductions. So, as I said, my name is Four. I work at Facebook um, in California, and my entire adult life I've been obsessed with the problem of intrusion detection. And those of you that have known me or worked with me can contest that that's true. Um, I actually think I've spent more time thinking about intrusion detection than any other thing in my whole life, which is actually kind of sad. But that's okay. So I love the problem. I've been working on it for a long time, and I want to talk to you a little bit today about intrusion detection. And it's one of those topics in security that you don't really see people talking about a lot, and frankly, I haven't seen a lot of people thinking a lot about either. Well, what I wanted to do in this talk is actually spend some time um, talking about how I think about intrusion detection and stepping through some approaches to it that I think are somewhat novel. Um, the goal is not so much to impart some major new discovery on you, but to help you think about this problem and hopefully have you come up with ideas to help me with this problem. So it's a little bit of a self-serving talk, I guess, in that way. Um, but my goal in this is to get you excited about the subject and to get you to come away with this from this talk thinking about new ideas in the field and ways to contribute. So that's my goal. So this is a talk in 3 acts. The first act is kind of discussing the state of the intrusion detection field. And in order to talk about the state of any field in security, you have to start at the logical place, which is money. Um, so the security industry is roughly a $3.5 billion industry in terms of money spent on security products. Uh, and that's according to Gartner. IDG, another research firm, did some analysis. I tried to come up with some numbers on how much money people are spending on intrusion detection products. And it turns out it's a little bit hard to pin down. But IDG released some information about SIEMs. Are you guys familiar with security event managers and the whole field of those products? So people were spending about $1.5 billion a year on those products, which is actually kind of a lot of money for things that don't work and do anything useful. So, um, and I'll try to show why I think that's the case over the course of this talk. So, okay, so people are spending money on products, but how well are they working for us, right? That's a natural question to ask. So, who can we turn to kind of to glean some information about how well these products are working? Well, one of the sources of that information is something called the Verizon Data Breach Report. Have you guys ever heard of this thing before? Yes, I'm seeing some nods, some not some nods. Yeah, actually, if you haven't seen this, I'm not the kind of security guy that like loves the Magic Quadrant or something like this, but this report's actually really good, and it's a pretty good summary of the state of the industry and so on. So anyway, in the most recent 2012 report, they have a few different data points in there that I think are interesting to illuminate this question of how well these intrusion detection products are working. So I'm just going to walk you through a few, I think, salient data points from that document. We won't dwell on this too much. I see some people like, oh my God, another data breach report. I won't spend too much time on this, but I think it's actually pretty interesting, and I hope you agree in a minute. Okay, so what does this tell us? 7 out of 10 targeted attackers are targeted attacks are against larger organizations. Okay, this isn't all that like surprising, right? But one of the things I do want to talk about is intrusion detection in light of these so-called targeted attacks, these so-called APT attacks or something like that, right? How well are these products doing against these targeted attacks that are happening to big companies? And so the current state of affairs is that half of intrusions took months or years to discover that they happened at all. Months or years to discover they occurred. That seems kind of like not very good. Okay. 71% of the time in the attacks surveyed, the attacks took place in minutes or less total time from to compromise a company. Now, let me just step back a minute for those that don't know about the Verizon Data Breach Report. It encompasses actually almost all the case studies that are public and a bunch of them that are private from places like the Secret Service and a bunch of other international law enforcement agencies, as well as Verizon's own incident response group. So it covers about 855 cases of actual intrusions and actual breaches that have occurred. So this isn't just some made-up numbers. This is actually based on actually a the single largest study of data breaches that's ever been done is this report. So anyway, okay, so those are kind of bad. Intrusion detection systems maybe aren't working that well, but let's put the nail in the coffin. So how are these things discovered in these companies in the first place, right? When they actually take months and years to discover, how are they discovered? Well, half of them are actually notified by a third party and not discovered by the company at all, right? The FBI comes and tells you something happened, or some law enforcement agency, or some other company tells you something happened. So that's like half or more than half of the cases. Okay, what about the rest? Well, a third of the cases are from somebody noticing, hey, something is weird. A system administrator noticing a process is running on a system that shouldn't be. Somebody that's non-security just, happens to notice something and notifies the security team. So we're actually up to a fairly sizable percentage of the case studies, and we haven't even gotten to the intrusion detection system yet, right? Okay, so they call these intrusion detection systems fraud detection systems in the report. 5% of the time of this particular study, again, the largest study ever done, 5% of the time, these intrusions are discovered by an intrusion detection system. The stack of dollar bills on the previous slide, right? This is what it's giving you. Now, 5%, now how bad is that really? Let's think about how that stacks up against other things. Well, it turns out routine log review, somebody randomly going and looking at logs, is more successful at discovering intrusions than the intrusion detection systems. Okay? What the hell? These things aren't working, right? Okay, you say, well, you know what? That's just a single data source, they're biased or whatever, some sampling error, right, or whatever. Okay, let's look at another one. So there's another report put out by a company called Mandiant. You guys heard of Mandiant before? Yeah? Okay. So they're like pretty famous for being like one of the big companies that handle APT, quote unquote, I'm using that, I know people don't like that term, intrusions. So they're called in when a company gets compromised by a nation state actor to help them handle the response, figure out what happened, and then remediate. So they actually come up with a report as well that kind of covers the same topic. And in their report, they say 6% of advanced intrusions are detected by an internal process, right? And in fact, the numbers that were detected by an intrusion detection system are worse, right? Because we already know from the previous slide that an internal process can include, hey, something is weird. An internal process can include random log browsing, right? So this is the state of the art. This is where we're at, 2012, intrusion detection, right? So, we suck, and we need to do better. Yeah, this is my we has a problem slide. It takes a minute. It's actually really funny. Okay, so maybe these numbers are wrong. Maybe these two different reports are telling us things that are the same, but they're still wrong. Look, I know you guys all do security, or a lot of you guys. You know these numbers aren't wrong if you've been doing this for a while, right? So, there's an intuition aspect to this as well, and I see a bunch of you guys nodding. So I think the question is, if buying a bunch of boxes and throwing them out there and plugging them in isn't really cutting it anymore, arguably if it ever did, what can we do, and how can we approach this problem and try to do something smart? So that's what we're going to start talking about now. And that's where we get into our second act of the story. Okay, so first of all, let's define what the problem is. The art and science of defining actionable deviations between normal behavior and attacker behavior is one definition I came up with for what you're trying to do when you're doing intrusion detection. This is kind of complicated, so maybe this is a better way to think about it. Right? You're trying to get lucky by detecting somebody doing something dumb. So what's a framework for us to think about this problem, and how do we actually approach this? All right. So here's the first thing. This is the rookie mistake that people make with intrusion detection, and 99% of the world people that do intrusion detection are making this mistake. So this is the example. If somebody wants to do intrusion detection, they buy an appliance or they buy a snort sensor, right? They plug it into the network, they turn on a bunch of signatures, and then they say, holy shit, there's a lot of alerts. What do I do? And so they go and they turn off everything that's making an alert, right? And then they're like, okay, sweet, now it's working, right? I mean, I'm right here. And so, like, what's the problem with this, right? People love the idea of an intrusion detection system that's going to always tell them the truth and never lie to them. And this is something we call the false positive fallacy. Right? And it's this idea that I'm going to build a perfect intrusion detection system that's always going to tell me the right answer, and it's never going to tell me something wrong. And that's my goal, right? And if I ever get some noise or if I ever get some spurious alerts or something, then the whole system's a failure, and I'm just going to turn it off and ignore it. And I think this is one of the fundamental problems with the field, is that people don't understand that this is the wrong approach. So this is a picture of somebody. The idea here is that people want to have something that wakes them up in the middle of the night, only if it's something that's really bad. And they don't know how to handle this stuff that's in the middle, right? It's very easy to instrument something that every time this triggers, I'm going to get alerted, I'm going to get in the fire truck, and I'm going to drive and save the day, right? But the reality is unfortunately more subtle than that. So this is something very important to this discussion, which is called the event pipeline. And this is the process by which you take an event or a signal or some sign of suspicious activity, and you sort of put it through this series of processes, and out the other end comes something useful. And so I'm going to talk to you about how you go about that. So the first stage is dealing with noisy events, learning to love noisy events. And that's what we're going to talk about now. So we talked about the example of the thing that wakes you up in the middle of the night, right? Well, let's talk a little bit more in subtle terms about things that are in the middle. So this is an example. I'm going to show you some examples from 1 to 10. I don't want to spend too much time on this, but let's say you have a taxonomy where you have 1 is I want to be woken up in the middle of the night, and 10 is like I never want to look at ever, right? And I want to show you that there's actually a bunch of stuff that is in the middle. So maybe you find, you've been talking to some peers, and you find, hey, we reversed this malware, and we found this malware going to this really weird domain name, and no one's ever going to go to that domain name ever. But if you look for that domain name, that's always bad, right? If you get lucky, that's actually pretty good signal. Okay, what about a PDF that's got some malware in it? Do you want to be woken up every time you have PDF with a malware? Depends on the malware, depends on the PDF, depends on the user, right? So now we start getting grayer and grayer and grayer, right? Different login geolocations for the same user, right? I mean, there's ways you can make this useful. Maybe they're traveling, maybe they're in another office, or so maybe it's a false positive, like you don't know, right? The point is, I'm trying to say is like this is from highest confidence to lowest confidence, and the point of my talk is going to be like, how do you use these other things, right? I think what a lot of people do is they just create an intrusion detection system and have them email them every time something happens. Well, if you email yourself every time these things down the list happen, you're going to stop paying attention pretty quickly, right? Okay, so anyway, I won't dwell on this too long, but NetFlow-based alerts for known bad IP addresses, so you get some IPs from somebody, but if you've done this before, you know there's some reasons why this can create some noise. Specific registry modifications, so like let's say you're watching your machines, and you know that the run once key is like an interesting place where people try to establish persistence, right? But you obviously don't want to get an email every time a registry key changes, right? That's not going to work out. So another example, antivirus alerts. Over the years, this keeps going down the list. This used to be up there. Now these are kind of down the list because they're not all that useful. This is an example I'll use throughout the talk. A snort event for a blank user agent, right? You guys know what user agents are, I hope. Maybe a blank user agent is interesting, maybe it's not. We'll talk about user agents. A successful RDP login. Again, not something you want to get emailed in the middle of the night, but it has some part to play in the intrusion detection story, right? Okay, a snort event that you write that gives you an alert every time there's encrypted traffic. So again, we're going down the list, noisier, 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 and noisier. And then the final point is raw data. Obviously, you don't want to get woken up in the middle of the night because you got a log. Hey, I got a log, yay, right? Doesn't make any sense. But again, they're an important part of the story. So how are they an important part of the story? Well, let's talk about it. Okay, so let's say we went through, we instrumented those 10 things. We have an alert for every single one of them, right? And we want to do something useful with these events. So how are we going to do something useful with them? Well, let's take an example. Let's take an example of the blank user agent one. Where is it? Right here. Yeah, 7, thank you. So let's take an example of number 7. All right, so every time you see a blank user agent, probably not something you want to be woken up about, but there is a way to make those useful. So blacklisting. So you create an event, right, and you send it somewhere that consumes those events, and then you want to go through a process on that particular event called blacklisting. The blacklisting is a process whereby you try and, so the whole goal we're trying to take is take those events from, as we go through the list, we're trying to take those noisy events and push them up to be as least noise as possible, right? That's the first stage we're trying to do. So if we can get the number 7 to be a number 4 or number 3, like that's actually awesome. And then when we get down to correlation, we'll actually figure out how to combine those number 3s together into something worthwhile. So how do we get the 7 to a 3? So the first step of that is called blacklisting, right? So blacklisting is about taking an event and taking out the known false positives, right? Sorry, I'm walking out of the zone. It's about taking an event and removing the known false positives. So let me give you an example. Have anybody ever written a snort event for a blank user agent before? Yes, no? Well, I have, because I'm lame. And I wrote one, and this was years ago when user agents were still interesting. You guys ever heard of Fitbit before? That thing you like walk around with and like tells you how many steps? Does that sound familiar? So it turns out Fitbit, like the people that wrote Fitbit, it calls back to some cloud service and like records your steps or something. And like they don't know how to program very well, so they actually forgot to include a user agent. And so one of the things you notice as soon as you turn on a signature, and if you have any users that use Fitbits, then all of a sudden you got a bunch of alerts, and you look at the domain name or the destination IP, and it turns out it's like some Fitbit thing. And you're like, okay, well that's probably not APT or something, like, you know, that's probably okay. So you start peeling back the layers to try to whitelist those things. So, and I admit, you know, people can be tricky and hide, and I get that. You have to make the call when you're doing the blacklisting yourself. So the point is, every single event type, whether it's a network-based event, a host-based event, a user event, whatever, you go through a process whereby you drop the ones on the floor that you know are just not worth looking at. Now, that's different than the model with the snort sensor we talked about earlier, right? Where you just plug it in and turn off everything. We're not turning off the thing. We're just turning off the ones that we know are bad. And we're letting everything else through. And we're being fairly permissive here, right? We're just going to take the most egregious cases and turn them off, because this is just one stage in the event pipeline. Are you guys still with me here? Is this making sense? Okay. Like, people look like they're falling asleep, but I think it's like the weird mood lighting going on, so it's kind of hard to tell. So the next step after you do the blacklisting, so that means you take off all the egregious false positives. The next step is something called identity translation. So this is my Superman changing his identity. The point is that one of the things that's really hard about intrusion detection in a modern enterprise is that a lot of the events come in and they're like apples and oranges, right? So you get an event from a network sensor, like a snort sensor or something, and it has a source IP, right? And you get some alert from some log or something, and it's got like a username, right? And this is actually like a really hard problem, and it's really subtle. But like, if you want to start doing interesting correlations between these different types of things that are alerting, you need to be able to do some translation layer so that you understand that this source IP is actually something to do with this user, so that you can start comparing the events together. So this is hard, and I've spent a lot of time working on this problem before, but it's necessary, because otherwise you'll never be able to compare events from your infrastructure to each other if you don't know that they're related. You have to have some way to relate them, right? So, you know, what I would recommend is to have some sort of system whereby you can tag these events with various identities after you've done blacklisting them. So you take off all the false positives, and then you just think of it like a tag, like you tag. And then you have a system that says, oh yeah, that IP at this time, I have a lookup table for that, using DHCP or something. And that was this user, or stuff like that. And if you're interested in talking more about how something like that works, because it's a little bit difficult, I can talk to you after the talk about it. But the point is, you basically just need lookup tables that are live. And there's a bunch of different commercial systems you can use for this problem as well. But it's pretty important. Okay. So we've covered blacklisting, and we've covered identity translation. So you think about that pipeline, and our little event that was really noisy is hopefully getting a little less noisy after going through these various stages. Now the next part of the discussion is going to be how you're going to take these noisy events and compare them together to create a meta event that is of use. Make sense? Yeah? You guys with me? Okay. So this is the stage called correlation. So we're going to talk a little bit about how to think about correlation in general, and then I'm going to introduce a concept that is going to be a specific type of correlation that you guys can think about doing. But there's other ways to do correlation too, and I'm not going to talk about those. But let's first talk about what correlation is in the first place. The idea is to take a bunch of low confidence events, like these 7s and 4s and whatever, right, and turn them into high confidence events, right? A combined event that includes sub-events that are more interesting than the individual events that you would never look at, right? That's the key. So how do we do that? Well, let's talk about a concept called the attack plane. This is not an attack plane, although I imagine somebody thinks it is. Actually, what I mean by an attack plane is something else. So the concept of a plane is, in this case, I mean like a two-dimensional space, right? You guys familiar with that definition of plane? Just think of it as a table that you can stack things on, like apples, right? And the point I'm trying to make is that the perspective you take when you build that desk that you're placing the apples on matters. And so let's talk about an example. Here's a very simple case. So in this case, this is my attack plane, this line here, right? And these things are the apples. These are individual events. These are noisy events that I want to combine together. So this is the trivial case of a way of grouping events that you can do at home, kids, that you can do yourself. And this is the way of grouping them. It's by IP address, right? It seems pretty natural, pretty obvious, pretty trivial, right? If there's like 4 events from a same IP over a certain time window, maybe that's more interesting than one event that I would never look at, right? So this is the trivial case of a correlation. And in this case, the attack plane is an IP address-based attack plane. The desk that I'm stacking these things on is an IP address desk. So let's see what that looks like. It looks like, okay, 1.2.3.4 has 4 events, it's over here. 4.3.2.1 is over here, and it's got 4 events, right? And depending on the nature of these bubbles, these events, this whole box may be something worth looking at, right? Maybe. Now, this is a simple case of grouping, and this is sort of the state of the art of correlation as it stands today. But are there different ways of doing grouping that could perhaps tell you something more interesting than simply stacking things by IP address? And it turns out the answer is yes. But we have to take a minor digression before we get there. So please forgive me for a moment. But this is going to be really interesting. The kill chain. Did I scare you? So the kill chain, who's heard of a kill chain? Anybody? Awesome. This is actually a really important idea in security, I think. And it's kind of a new one, and I think you'll find it interesting. So the idea of a kill chain was started by the US military. And it's a theoretical concept that breaks what a physical attack, right, like a terrorist attack or a whatever, it breaks those attacks into a series of stages. And it says, an attacker who's going to attack me has to go through these stages, no matter what. They have to buy a weapon. They have to load the weapon. They have to like figure out where I'm at, right? They have to come to me, whatever those stages are. There's a bunch of papers on the kill chain in the military context. And in the military context, they use this concept to figure out how they can do 2 things. Break the kill chain in the case of an attacker, right? So how can they say, an attacker has to necessarily go through these stages. Where in that could we actually mess them up, right? And it's actually pretty useful for that. But it's also useful on the other side when they're trying to kill people uh, for trying to figure out how to accelerate your kill chain. So one of the things in the kill chain is like, I have my sight on the target. I got to call HQ and confirm my orders, right? And HQ is like, well, it gets back to them. So one of the problems is like delays in communication slows down the kill chain. I'm not advocating killing anybody or anything like that, by the way. Don't get the wrong idea. I just think it's a cool idea from there that we can borrow for information security context. So anyway, so that's the deal. So does that make sense? So these three guys at Lockheed Martin actually figured out how to borrow this concept and bring it into the information security domain. And it's a cool paper. You should read it. But what they've done is they basically go through what an intrusion attack looks like from a kill chain standpoint and figure out, using that, how we can stop it, how we can prevent it, and so on. So here's my version of their paper's kill chain. I made this up, but their paper has a slightly different one. This is my version because I made it a little different to optimize for intrusion detection. So here's what an attacker might do. They might do some recon, right? Try to figure out what your network is, where your IPs are, what domain names you have, do some Google searching. Most of this stuff is passive. They also might set up their C2 nodes, right? They might register the domain names, right? Does this sound familiar? Hopefully. Delivery. How does delivery normally happen these days of an exploit? Spear phishing, yeah, SMTP, right? Email. It's pretty common. There's other vectors, right? That's the most common right now. Yeah, so delivery. So that's a good, important part of the kill chain, right? Like, something has to go across the mail. Exploitation, right? The computer gets compromised. The machine, usually has a downloader or something in the payload, downloads something, and then starts calling back to a C2. I mean, obviously, there's subtle differences in how people go about these things, but I think this is pretty good. Somebody takes over the C2, becomes active, then actively manually compromises the machine, right? This is the part where they're like dumping the hashes, right? Doing password cracking maybe if they need to, or doing some other machine analysis. Then there's internal recon, where they look around your network, try to figure out what kind of stuff you have going on. This is where they look at your wiki and see the wiki page that says, here's all our admins that have access to the awesome stuff, and here's their passwords. So that's the part where that happens. Lateral movement, so they're logging into different machines. Sorry, I'm kind of maybe going too slow here, but persistence, setting up a way to connect back into your network, and then staging and exfiltration. So are these stages and these concepts familiar at least? Right? Yeah. So this kill chain, the notion that these things are linked and by and large are necessarily done by an attacker is actually kind of an interesting concept for us, right? So let's go back to where we were a minute ago. We were talking about attack planes, right? And we had this trivial case of an IP address, and we were stacking these events on this table. Well, what if we had a more sophisticated idea? What if we used the kill chain that I just mentioned, that these attackers necessarily have to go through? What if we use that as the basis for our correlation, right? Now again, this is just one idea for how to do more advanced types of correlation. You probably have other ones, but this one's interesting. So let's say you have a command and control event, right? Maybe it's a low quality event, but maybe it's some sort of, maybe it's the dumb case of the blank user agent or something. When that event comes in, maybe it's a 7 out of 10, but you have a label on that, and when the event gets created, it's labeled with the kill chain stage that it belongs to. Okay? Exfiltration, right? Maybe you have something for exfiltration. Maybe you have something for internal recon, right? Maybe you have something if somebody looks at too many wiki pages in too short amount of time, maybe that's an event. Again, not an event I want to get woken up in the middle of the night, but an event you can label with the internal recon part of the kill chain. And exfiltration, maybe you look at some large amounts of RAR files going out of your network, just as an example, right? So beforehand, maybe each of these things, like I've color-coded this by how the quality of the signal, maybe these are kind of bad, and this one's kind of good, right? But maybe they're still below the noise threshold that your response people can handle. But now, you've been able to, since you did identity translation, these network-based events, you know they were user Bob, right? There may be other users that could have been tied to. We can talk about that after the talk if you want to. But let's just say, for simplicity, that you know that's user Bob. You know that this was user Bob, and you know this was user Bob. Now all of a sudden, because of the fact that those are tagged with the kill chain stage, you now have a much more interesting correlation than just a bag of things that an IP address did. So anyway, that's just one idea of how to do correlation, but there's a bunch. Okay, so recapping on that part, noisy events are an important part of the story, right? If you're not figuring out a way to use noisy, low-quality events in your intrusion detection system, you're doing it wrong, right? Because you're never going to be able to come up with the perfect alert that's going to wake you up in the middle of the night and tell you everything bad is happening. That's not how it works, right? So you need to really figure out a plan for how to deal with these noisy events. You reduce the noise as best you can on a per event basis by blacklisting, and then you figure out some smart ways to do correlation. Okay, but we're not done. We are not done. There's still 2 stages left. So after we're done with correlation, we do something called applying context. Now, this is something that came out of context. Does anybody know what this is from? Yes, it's from Star Trek, the old one. And I have no idea what this episode was about, but it looks really weird. Anyway, context is really, really important because it helps you speed up analysis. So what am I talking about here? The idea is like, so you've got these events, they've gone through this pipeline, they've gotten blacklisted, they've gotten improved, they've gotten better. Now you have some things that you think are pretty good, right? And at some point, somebody's going to have to look at those with their eyeballs, right? Now what you want to do is you want to minimize the amount of time it takes for somebody to look at those things with their eyeballs, right? Because you have a lot of these things, and you want to be able to, look at as many as you can. So context is such a valuable point and something totally missed by most people. The idea is that as soon as you get a set of events that you think are important, then you can start pre-applying information about it from your environment that's interesting. A lot of people think, well, how can I just get all my data sources together and build intrusion events? Yes, but how can you also use those same sources of data to apply context? An example, what if you had a system that had a correlation and had an interesting event, right? But what if you wanted to see what tasks were running on the system on a Windows machine at the time in which you were looking at the event? Now those tasks, the list of tasks, wasn't part of creating the event in the first place, but it's actually super valuable when you're looking at it, right? Does that make sense? And so there's actually a ton of data like that, right? Maybe some data from your logs, maybe some data from your network forensics system, right? A bunch of PCAP data, or I don't know, you probably have better ideas. But the point is, applying data before the analyst looks at it can actually make the analysis of it much more palatable. Okay, I think I covered all this. Yeah, so let's say you buy some fancy schmancy vendor appliance, you can actually use that to provide context on events that thing didn't even create in the first place. Most people miss that point, right? Okay, and then of course analysis. So somebody's got to look at these things. Actually, what's funny? There was a time in my career that I wanted to make so that no humans ever had to look at this stuff, and that there would never be a human in the loop. And I gave up on that after a couple years of trying, because I don't think that's possible. So this is actually a real picture, I think, of the AT&T knock, which is kind of insane. This is not what the Facebook SOC looks like, but it's a pretty cool picture. Anyway, the point is, you want to look at these things, and you want to be able to look at the minimum, the most impactful, most useful events as possible with the most context pre-applied, so you don't have to do a lot of work. Right? We're lazy. Okay, this is the end. So I just want to say a couple things. So one of the things that I'm frustrated about in security is you go to a lot of conferences and everybody is always excited about talking about the latest O-Day. And I mean, I think that stuff's really great and cool. But I think the problem is, how many talks do you go to where somebody's talking about some cool defense thing, some cool way to stop attackers, right? Why is there nobody thinking about that stuff? I mean, there's some, don't get me wrong, but it seems like the security community is really focused on attacking stuff. And I think partially because defense is hard. And I don't know if we even really know how to do it right. So Anyway, that's like my thing. I think people should spend more time on figuring out how to do defense right, because we're in a pretty bad state. I mean, I showed some of the intrusion detection numbers earlier, but that same presentation could be made about defense in general, and things are pretty bad. So anyway, thanks. I'll take questions if anybody has any.